this question here, you're being asked to draw the product of the following acid-base reactions if treated with one equivalent of a strong acid like HCl. This is the same thing we did in 2A, if you already looked at that one. All right, so again, we just want to figure out which of these atoms is going to act as a base, because we're using an acid here. So one of these atoms in here, it's either going to be the oxygen, the nitrogen, or the other oxygen. One of them is going to act as a base and pick up that proton. We just have to figure out which one is most likely to do it, since we only have one equivalent. All right, well, a couple ways we can do that. The first way is, let's look at these, and let's figure out which of these is most basic. And the way we can think about that is asking ourselves, what does a base do? It's going to send its electrons out to pick up a proton. Well, we just need to think, how available are these electrons? Is the oxygen going to come here and grab that proton? Is the nitrogen going to come here and grab that proton? Or is the other oxygen going to do it? Well, whichever one is not hanging onto its electrons as tightly is going to allow those electrons to be more available to pick up that proton. So when we look at these three atoms, two of them are oxygen, and oxygen is more electronegative than nitrogen, which means the oxygens are holding on to those electrons more tightly, which means they're not as available to go out and pick up that proton. But the electrons on nitrogen are more available because nitrogen is less electronegative. It's not hanging on to these electrons as tightly, so they're more available to act as a base and grab that proton. So we already know the nitrogen is the thing that is going to get protonated here, okay? So the product of this one is going to be this species here, where the nitrogen gets protonated, and it ends up with a positive charge. Now, the other way we can evaluate this is, let's just show what happens as each one of these gets protonated. Okay, and as each one, oops, forgot to put the nitrogen there. As each one gets protonated, they're going to get a positive charge. So let's just compare the stability of each of those. So here I'm putting the proton on the oxygen, and I'm giving that a positive charge. And here I'm going to put the proton on the other oxygen, and I'm going to give that a positive charge. All right, so we want to basically ask ourselves here, which one's going to pick up the proton? It's the one that's going to handle the resulting positive charge the best. So in each of these, we have 1 unit of positive charge. In 2 of these, we have that positive charge on the oxygen. And as we already said, oxygen is more electronegative. We already know from the top it's not going to send its electrons out to pick up that proton as easily. But now we also know it's not going to handle the positive charge as well because it's more electronegative. Nitrogen is less electronegative, so it handles that positive charge better. So whether you evaluate the stability of this conjugate acid here that I'm circling, or you evaluate the basicity of these electrons, it's going to tell you the same thing, and that is that this is going to be the product because the nitrogen is the one that is going to get protonated.